Ladies and gentlemen, good afternoon. I would like to welcome all of you for this special session. And my job is to introduce USJI and USJI as an institution. I have to tell you about what it is. Second, of course, I have a pleasure to introduce you today's speaker, Vice Chairman of East Japan Railway Company, Mr. Masaki Ogata. And before doing that, I have to thank, in abbreviation, JSPS, equivalent of NSF in the United States. Am I correct in saying that? Yes. We would like to, all of us should thank him to let us use this city. Thank you very much. Now, USJI is an NGO established in April 2009 by 5 Japanese universities. And I went to Keio University, and Keio University. I taught at Waseda Graduate School, so Waseda. And I didn't go to Tokyo, nor Kyoto, nor Ritsumeikan. These 5 schools got together. Can you imagine they established an institution in the United States to study together, to form an opinion on Japan, and to express our opinion clearly to the United States and beyond, of course. That is the purpose of our organization, and we are having many sessions like this kind of professional discussions, and also twice a year we have a special week for topical discussions on US-Japan relationships, etc., etc. So today we are going to hear Mr. Ogata's speech on the unique relationships between high speed of railway and its connection with environmental issues and natural disasters and all that. He studied, if I looked at his experiences in the file, he started with the mechanical engineering side, rolling stock. But then he went to management. So it's a combination of everything. But now he's the executive chairman of East Japan Railway Company. And we should welcome Mr. Ogata with a warm applause.
Thank you very much, Professor Abe, kindly introducing me. And my name is Masaki Ogata, and the Vice Chairman of East Japan Railway Company. It is my great honor to be here with you and make presentation concerning with our railroad systems and of course the future of the high-speed rail. So I think it's going to take, today I just pick up 2 topics. So, and also a document has been already distributed on your table, so you can check later. And this document includes 2 topics. One is, of course, low carbon society, carbon dioxide emission, and another one is just our countermeasures against the natural disaster, including, of course, tsunami and earthquake. So it will take, I think, 15 minutes each, so totally 30 minutes. And then after, I'm very happy to receive any questions for me. So, firstly, I'd like to talk about CO2 emissions and energy consumption statistics, and also our energy saving performance, and move to features of Japanese railroads. And I'd like to conclude our challenge for energy efficient society. Firstly, of course, CO2 emission and energy consumption statistics. This graph shows you the basic idea of the CO2 emission from the fuel consumption and horizontal line, total final consumption for energy. So of course, United States of America consumes a lot, and also China consumes a lot. They have a very large size of population. Japan here, last year, and also France, UK, Germany around here. And this shows you a world average. But maybe it's better for you to take a look at the share of the transportation industry in carbon dioxide emission and the energy consumption. Upper half shows you the total carbon dioxide emission in the year of 2008. And you can see also energy consumption. And in this figure, maybe, of course, energy consumption and the CO2 emission is kind of a very have a very proportional figure. And so I'd like to just express about this size. And also, USA consumes a lot of energies and emits a lot of CO2 emissions. And this color in red shows you the share of transportation. So it is very clear that United States transportation shares a lot of share in energy consumption and also in terms of CO2 emission. And the upper half side below is just CO2 emission per capita and energy consumption per capita. And of course, USA still has a large share in transportation. And this is Japanese cases. And the transportation shares rather a smaller portion of the total industry. And this might be a very good, graphs for you, because the vertical line is corresponding to share of transportation industry. This professor, can you see? Okay, maybe. Thank you. And also horizontal axis corresponding to energy consumption per capita. And then, what we can tell from this graph, USA consumes, of course, a lot, and also share of transportation is very high, much higher in comparison with other countries. And this is world average. So in the world average, share of transportation might be around quarter in all the industry. And also Japan, France, Russia, Germany, UK is in such a very small circle. So it looks similar. And in case of India and China, the share of transportation industry is rather lower because I think that they are just in the stage of developing in terms of transportation industry. So maybe we can derive many lessons from these graphs. And this shows you carbon dioxide emission in Japanese cases. So this shows you the total carbon dioxide emission for all the industry. So in Japan, as you have seen in the former graph, Japanese transportation consumes just a quarter of all the industry, and all the industry. In this case, maybe statistics is a little different, and looks like world average. In this case, this derived from a ministry-run infrastructure, transport, and tourism in the year of 2008. So maybe base of the statistics is a little different from this. But anyway, 90% transportation shares 19% in the total CO2 emission in all the industry today in Japan. For example, industry, just residential, others, energy conversion, in engineering process, something like that. And within the transportation, rail shares only 3.4%. So very small portion of the CO2 emission in Japan today. And also, still, even though rail shares a very small portion of CO2 emission in Japan, railroad carry about 30% of passenger transportation in Japan. So we can know that the mode of the rail in the transportation is a very efficient mode for also in terms of emission of carbon dioxide. And also from another approach, This is a comparison of carbon dioxide emission per passengers and by transportation mode in the year of 2008 in Japan, of course. And the passengers cars consumes and also emits the carbon dioxide emission per passenger. This shows you the carbon dioxide emission per passenger. Okay, maybe this is very proportional to the energy consumption, of course. And passenger car, aircraft, bus, rail, and rail over cases. So rail just consumes maybe 1/7 something, 1/8 or 1/9 of passengers cars, and very efficient mode of transportation. And we are rather efficient in comparison with the other railways. Now I'd like to move to evolution of energy saving performance. This shows you a year, and left-hand side shows you conventional trains or bus, and right-hand side shows you a high-speed rail. About half century ago. So our train like this. So index for energy consumption at that time, suppose 100%, and by the maximum speed of 100 kilometers per hour. Today we have a very progress type of EMU. EMU is a electrical multiple unit. EMU in Japan, we are using EMU, electrical multiple units, not a locomotive. All the coaches have a motor beneath the floor, and also in this case 47. So we have already have the energy consumption since last past century, and we are going to improve furthermore. And in case of high-speed rail, in the year of 1982, energy consumption, for suppose we put the index to this energy consumption 100 by the speed of 240 kilometers per hour. Today, we have a new E5 series, and it was debuted March the 5th, just one week before the earthquake. And it was March the 5th, and it's just run for less than 1 week. Then we have the earthquake. But right now, it's okay. It's just resumed the operation, of course, and it can run at 320 kilometers per hour, 200 miles per hour, but still consumes less energy. So by using these kind of technologies, I'm going to just let me explain about these kind of technologies. Firstly, I assume that as you may know here, firstly, regenerative braking system. It is very usual today in Japan, and suppose this is a train A. Of course, in Japan, train composed of 10 cars or 12 cars or more than 15 cars. But suppose this is I simplify. This is train A, train B, and so proceeding train, following train. Then, train A is accelerating and train B is accelerating. So our power supply comes from a power supply station, of course. But if the braking adapts for the train A, traction motor works as a generator, and then train A can provide the energy to train B when the generative brakes are applied. So no need to just receive the power supply from the power supply station. In this case, just we can use the energy, we can move the energy from A to B. And also second technique, variable voltage, variable frequency power control. And when we can use this power control system, energy efficiency is almost nearly 100%. Thirdly, reducing the body weight by adapting aluminum bodies, bolsterless bogies, and other technologies. So, for the conventional trains, we have successfully reduced 30% of weight, and also for high speed, we successfully reduced the weight down to 23 by the 23%. So now today in Japan, we are using a very lighter body. Thirdly, I'd like to move to a features of Japanese railroad. So we have a lot of features. Japanese railroad has a lot of features, and of course, safety is a top priority. Our company was established 24 years ago. Before that, in Japan, the former Japanese National Railways just operated a train. But 24 years, our company was, Japanese National Railways was privatized and divided into a 6 passenger company and 1 freight railway company. And we are one of the 6 passenger company. And since then, safety has been and is and will be the top priority for our company. And of course, punctuality, high speed, high frequency, large capacity, through service. And this picture shows you the coupling and uncoupling technology. And these trains can be coupled and also uncoupled at the intermediate station of high-speed train between origin and destination. Thus, this train on the right-hand side can make a through services from the exclusive guideway to conventional lines. So many United States people in railroad are especially interested in this type of train because, for example, in the case of California, these trains coupled together can run from Sacramento to San Jose to Los Angeles down to San Diego, of course. But this type of car can run also into San Francisco instead of Sacramento. So this one comes from the north and south to Sacramento, and maybe uncoupled at the intermediate station of San Jose. And this goes to Sacramento, and this goes to San Francisco, like that. So this kind of technology is very important. And also disaster countermeasures like earthquake and heavy snow and heavy rain. And of course, environmental friendliness, just I have mentioned already. Comfort. Suica is a smart IC car. Today, time is very limited. So if you have any question, I have been engaged in the development of Suica. And also commercial development of stations, cost efficiency. And maybe at every time I'm telling about this fact, we do not receive any subsidies from the local government and the central government. Many foreigners were very surprised. Never, no subsidies at all. We just can produce a profit by ourselves. Instead of subsidy, we pay the tax to the nations and the local governments. And this figure is a very original graph. I made it. And also, I just made this kind of relationship. After I just made many talks with people of a high-speed rail in the United States. On the upper half, you can see many factors concerning with the shortened total trip time. Just I have talked with Professor Abe. Even though you have the very fast high-speed rail, if you wait in the station for 1 hour, it is meaningless. In Japan, maybe I need only 3 or 4 minutes because I am get used to 3 or 4 minutes before I get on the high-speed train. No waiting time, no queuing, actually. So shorten total trip time, including last 1 mile. Last 1 mile from your home to the station, and also last 1 mile from the station to your destination. So shorten total trip time, including the staying time in the station, is very important. And of course, shorten total trip time is strongly related with the through services, interoperability, and also renovation of existing facilities. Through service can be made by the renovation of existing facilities, and also direct connection to urban centers with high-speed rail. So we have to have very good connectivity at the terminal, such as Union Square, in the city, and connections to the conventional lines. So in Tokyo, we can enjoy these kind of good relationships between each other. And also, in the half down there, we have developments around station, including consistency with city plan and regional developments, and efficient land use, and also benefit to entire society, including job creation, generation of tourism demand. So we have all over these factors. In Japan, if there are not high-speed rail, we need more airplanes, more cars, more congestion, and other problems. So our characteristics of the management of East Japan Railway it's threefold. Firstly, we own, operate, and maintain all the railway infrastructure with all the other activities of the railway operator. We have station, we own land, we own stations, rolling stock, track, electric power supply, everything. And also secondly, we own all kinds of systems related to energy, especially electricity, from the supply side to the demand side. Actually, we are the single one and only railway company in the world which holds electricity generating plants. We have one hydraulic power plant, and we have one another thermal power plant. And our train in the metropolitan area can be operated by our supply. So, of course, you know today's power supply shortage problem in Japan. So, but in that case, we are okay because we can operate by our trains, by our own power supply station, hydraulic electric plants. Thirdly, we implement all stages in the whole life cycle of rolling stock. We have the manufacturing company. So we have the only one railway company in the world which owns the rolling stock manufacturing plants and thus have all the cycle, for example, concept, development, and also development, design, manufacturing, operation maintenance, feedback for new rolling stock development, and so on. So finally, I'd like to show you our new challenge for future. This shows you improving our transportation services by through service, barrier-free station, and seating services. And also, we strongly recommend that to use just only one transportation mode, like a combination of automobile and highway. But instead, we just recommend that maybe for the last 1 mile, maybe we can share the cars and buses and station, high-speed rail and destination, and maybe we can share also cars or buses, bicycle, and other mode of transportation. So we should make a better combination of many transportation modes. And thirdly, our challenge for a very energy efficient station, so-called ecosystem means the environment Earth conscious station of East Japan Railway Company. Thus, we can save 40% reduction of CO2 emission in stations. So we just are challenged for these kind of new technologies. Thirdly, this shows you are developing a stored power electric multi unit system, and this is just can be run by the battery, and this between the station and station run by only the charged battery, and at the station within a very short time it can be recharged with the supply of a power supply from the power supply station, and but anyway, this car can be charged in the station. So we do not we don't need to have a electrified section, and no catenary, no support force. Finally, I will show you, because we have a power plant, thermal, one hydraulic. So we have power plants. Of course, we have trains, we have hotels, we have stations, we have rental cars, systems. These are the subsidiary company operates over us. And also, if we have good energy management, we can just show you the very good example of the smart grids to the society. So right now, we are challenged for these kind of things. We can do that in our company. Conclusion, railroad, maybe later you can read it. So anyway, I will conclude railroad is the most efficient mode of transportation in today's Japan, but not only in today's Japan, but also in the world. So we really would like to contribute to the technology and also progress railroad in the world. We can contribute to the global environment by railroad innovation that leads to energy efficient low carbon communities. Now, I'd like to move to the March aspect under our responses. So maybe you have all known very well, and the strength of the earthquake on March 11th is magnitude 9.0 on the Richter scale, the largest in the recorded history ever in Japan. And you had the earthquake of 5.6. So 9.0 is 30,000 larger than 5.6. And this is the epicenter. And our territory, our managerial area covering east part of East Honshu Island, largest island. Maybe you are going to be very surprised to get to know that. Number of aftershocks. This is a frequency per day. So on March 11th, we have about 150 earthquakes, which surpasses the magnitude 5.0. And this is October, we are right here. So this vertical axis correspond to a cumulative number of aftershocks. So we had already 550 aftershocks, which surpass the magnitude 5.0. So this is virtually very important because we already have derived many lessons from the past earthquake. This shows the past earthquake, 2004 and 1995. This earthquake happens in the west part of Japan. And this earthquake happened in our territory. And also this one is maybe newest, magnitude 9.0. Our policy is always derive the lessons from the past disaster. Firstly, according to these lessons, prevent collapse of virus. Secondly, detecting system. Thirdly, preventing train from a large obstructive deviation. And also fourthly, operation in case of emergency, education and training. Thus, you can see, this is the Great Hanshin Awaji earthquake in 1995, 16 years ago. This happened in another territory, west part of Japan. So this picture shows you some very important lessons. We derived the lessons, even though this happened in another territory. We reinforce our pillars. So this time, March 11th, as for the buyer, a seismic reinforcement to prevent shear failures. We have to avoid shear failures. In this time, we don't have any shear failures. And no critical disruption to major structure. By the earthquake this time, only bending failures. Bending failure is also important, but it's okay. We can just demand the bending case of bending failures. We can repair. It's very thin. This is a definition of shear failure and bending failure. So maybe you can see it later on your document. So this shows you the second countermeasurement against earthquake. Early earthquake detection system. So earthquake, in general, composed of two factors. Primary waves of course comes first, and secondary wave follows. And so thus, we just take this kind of mechanism. We installed the coastline seismometer alongside the coast. And of course, we installed the seismometer just down the structure. But in this case, coastline seismometer catch the primary wave and then transmitted the signal to the substation, power station, and power shutdown, and the high-speed train automatically detects the power shutdown and adapts the emergency brake. Maybe I'm going to show you again. Primary wave comes first. Coastline seismometer catch it and transmitted the signal, and emergency brake adapted after the power shutdown. So, thus, we have already installed seismometer along the Shinkansen lines for 81 locations, and we have installed seismometer along the coast 16 locations. And in this case, on the March 11th, here is the epicenter. Here was the epicenter, and we have a high-speed train right here. And at that time, we have 27 high-speed trains between Tokyo and Shin-Aomori, 700 kilometers, about less than 500 miles. And two trains running at approximately 168 miles per hour through the Sendai area, maybe like there. And were exposed to strong shaking from the earthquake. The power supply to these trains was cut 9 to 12 seconds before the first vibration arrived and the emergency brakes were applied. The largest vibration came to these trains approximately 70 seconds after their emergency brake were applied. By then, it is likely that trains had slowed down to a speed of about 63 miles per hour. This shows you the mechanism of that kind of things. For 3 seconds, first 3 seconds, power supply halted after earthquake detection and emergency brake applied. Then reduce the speed from 168 miles per hour to down to 63 miles per hour, and finally stopped, safely stopped. And also third countermeasure is that kind of L-shaped car guide. This shape is L for character, large character L. And we just have already installed this very special device. So this time we don't have any derailment, but even though high-speed train is delayed, this is the wheel, and this is the wheel, and this is the rail, and this is the rail. So this wheel should on the rail, of course. So this is the figure of after the derailment. In that case, this type of new device, L-shaped car guide, preventing a major deviation, and train can last very straight. Train can last very strong as straight, just straight. So it's okay for the train because it runs very straight. And also, we just developed a guide groove insulated ray joint because from the last aspect in the year of 2004, derailed Shinkansen high speed just broken all these things. So we just improve the shape of this kind of device on the track. And also, this shows you countermeasures against tsunamis also. Example of countermeasures against tsunami. Establish hazard maps in advance for all the local segments of the line along the seacoast. And also prepare a manual for train crews and station staffs. Carry out training for train crews, station staffs, and operation staffs, and repeat this training regularly. Repeat it again and again. And for 3, Operation Control Center dispatchers commanding evacuation. If impossible, the crews voluntarily evacuate passengers to the safer places designated in advance by local government. So this is a scene of a training. At the time of earthquake, as I mentioned, we have 27 high-speed train operation, but we have also another 670 conventional trains in operation at that time. But finally, as for the Shinkansen, as I have already mentioned, a seismic reinforcement and the early earthquake detection system and so on, we didn't have derailments, no derailment at all of commercial trains. As for conventional trains, station staffs and train crews successfully led our customers to the emergency evacuation places designated in advance before the tsunami hit. So finally, customer fatality is 0 and the customer injury is 0. Of course, we have some damaged places, damage caused by the earthquake. For Tohoku Shinkansen, conventional lines, we have damage like, for example, tracks and the other things. So this shows you the condition of March 12, just one day after March 11. So many lines many lines suspended its operation, but however, today it's okay. We have 7 missing lines. These 7 missing lines was completely washed away with the entire city and towns, unfortunately. But still, we have 7 missing lines. But besides that, 7 missing lines, all the lines has been already recovered. Especially Shinkansen operations were completely restored on April the 29th, 49 days after the earthquake. And at that time, staffs and workers working on the restoration per day was about 8,500 at maximum. So I'd like to extend special gratitude to your country and to your people. Operation Tomodachi, Tomodachi is a friend. Operation Tomodachi, more than 20,000 soldiers participate. And also Operation Soul Train, recovery for the station. This is a station. I'd like to extend special gratitude to your country. So we will never ever forget what you have done for us. Thank you very much. And so devastating aspect of Japan, safety is top managerial priority. And also we have thoroughly implemented countermeasures for earthquakes, tsunamis, and other natural disasters as our policy of safety. Though the huge earthquake of magnitude 9.0 was the largest ever recorded in Japan, the consequences showed that our countermeasures were effective against the earthquake. We will examine the result, derive lessons again from the earthquake tsunami this time, and further improve safety of the railroad continuously. Thus, we share our experience with the world and contribute to the advance of railroad technology throughout the world. Thank you very much. Thank you very much for your attention. And so, I'd like to receive any questions, please.
Thank you very much. Very interesting speech. I would like to open the floor for questions and comments. Okay, I would like to go from right to left, and sometimes boys and girls. Okay, from you. To start with.
Yeah.
On the right-hand side.
I'm Masaki Takahashi with the World Bank Power Engineer. I have been very impressed with your presentation, although this is the third time I hear from you, especially the presentation of videos showing the stop the Shinkansen line after detecting the first wave. 90 seconds later it came, and 100 kilometers it has been reduced. But my question is, how unlikely the train will derail compared from 270 kilometers per hour to a reduced speed of 100 kilometers per hour? Intuitively, slower is better, but how unlikely, if you have any quantitative answers, I would like.
Oh yes, quantitative. Okay. My answer might not be a quantitative, but your question is very good question, I think. And the probability or unlikeliness of the derailment do not depends on the velocity, do not depend on speed. Even though the speed is very lower, actually high-speed rail is derailed. Actually, as I have mentioned in here, no derailment of a commercial service. 27 trains in commercial service. But we have one derailment at that time on the Master derailment. That is a test train, and with a very lower speed, and just get into the station from the depot with a very lower speed. And maybe the place of derailment for the test train underneath structure might be very special one. So right now we are analyzing it. So my answer is that probability, or in vice versa, unlikeliness, it doesn't depend on the speed itself. But the important point is that, of course, if derailment occurs at some certain point, if the speed is much higher, damage is going to be larger. So we have to reduce the speed. Probability, it doesn't depend on the speed anyway. Lower train is not necessarily be able to avoid the derailment. Maybe in some cases, high-speed train with a much higher speed running might be able to avoid the derailment. It depends on other factors. But what I would like to emphasize is that if the derailment actually occurs, speed should be lower. Of course, just the stopping situation much better, because after many effects after the earthquake and the derailment is much smaller. So that's the reason why we'd like to reduce the speed.
Thank you for a very interesting talk. I'm Jean-Paul Richard from the physics department at the University of Maryland. My question has to do with economy, actually. How is the cost of consumer decided And is there competition or not? I think that's an important issue always in the US in particular.
You mean consumers, interest in the cost? Cost for operation?
No, to use the train,
To use the train,
the tickets.
tickets, yes, okay. Actually, for example, you'd like to know that our fares and charges of tickets, maybe, actually numerical order, you'd like to know the level of
No, in which way is it determined? Is the government as a role?
okay. Actually, our fares, this is, I often receive such questions. The system of our fares and charges, okay, we always decide, but actually, fares and charges should be approved by the government. So in that terms, fares and charges is strictly regulated by the government. There exist some exceptions. But okay, but it is okay for us because for the past 24 years since the privatization and division into several passenger companies, we are one of them. We had never raised our fares and charges for the past quarter century, and maybe next quarter century we are not going to raise our fares and charges, even though the price index goes higher. Yes, because we are producing a profit still, and it's okay for us. Just keep the stable fares and charges and provide the much more higher quality service to the customers.
Thank you.
My name is Tung Ji Lu, LU, and I'm a retired American Police Service officer. And I went to Kyoto University in 1964 from Taiwan.
Yes.
Then I left Kyoto University in 1966 for United States. I still remember
Yes.
when I first took the high-speed Shinkansen high-speed train
Yes.
in New Osaka
Yes.
to Tokyo.
Tokyo.
That time, I have feeling so amazing, such a high speed, service good, safe, and so on. Now, after course of 45 years since I left, and ever, I returned to Japan many times.
Yes.
I have taken several times Shinkansen.
Yes.
My feeling all the same, fast,
Yes.
service good, and safe, punctual.
Yes.
My question to you,
Yes.
in the course of 45 years,
Yes.
what kind of improvement in terms of technology?
Yes.
For instance, you mentioned about maximum speed from 1982, 240 kilometers to today, 2011, 320 kilometers. That's one kind of the improvement.
Yes.
What else you can summarize to share with us? Thank you.
Thank you. Very good question. Thank you very much. Of course, as you have already mentioned, we inaugurate the opening of Shinkansen is between Tokyo and Osaka, and is in the year of 1964. So
64,
almost
yeah.
47 years has passed since.
47, you're right.
October the 14th is yes, and October 1st we have already passed 47 years, and of course maybe quality among the main qualities, higher speed. Maximum speed is also one of our improvement from 200 kilometers per hour to 320 kilometers per hour. And also, I think safety has been improved very much. Of course, we do not have any fatalities and casualties for the past century. It's okay, but still, maybe you cannot see. Statistics shows us no fatalities, no casualties. But still, in the background, safety has been very much improved. So this is a very important thing. And also ride comfort. Ride comfort has been very improved. For example, even though we have a much higher train, much faster train, like a 320 kilometers per hour train, we always try to put the cigarette on the table, and we don't try to just move. We don't try to just fall down. Just put the cigarette, even on the curvature, just put the cigarette as it is. And we'd like to keep the cigarette just standing from this origin to destination. So that we have already adapted many, of course, automatic tilting system, controlled by the computer. You can, this is invisible, you can see that, but we have adapted that. And also we have adapted many other improved devices. And also, fourth one is environment friendly. You know, energy, moving energy is parallel, proportional to the speed, 2 square of the speed, right? So even though we have a faster high-speed train, we reduce very bad impact for the environment. So for example, we reduce the level of noise down to a very low level. So also the environment friendliness has been improved very much. And also punctuality, reliability has been improved. So this is our challenge on the everyday basis. Did it answer to your question?
Yes, yes.
Maybe if we have a time, we can sit later.
Yes.
Thank you. I'm Gordon Thompson, Lyndon Foundation. First of all, may I suggest and hope that you would take your presentation to the American government, both to the executive branch in support of some of these ideas, and to the Congress to contest some of their ideas. As an economist, though, you won't be surprised, or I will not surprise you by focusing my question on profitability. One of the very damaging characteristics of the American government proposal for high-speed rail is it could never be profitable, that it would always require government support. You are profitable. But there is a huge difference between American rail, which is strictly rail, and your company, which has all of these other services combined.
Yes.
Could you strip out from your organization just the rail operation?
Oh, yes.
And tell us a little bit about its profitability. I suspect that your overall profitability depends on support of the rail system by the profitability of the many other services. Is that true?
Okay, so maybe I'm going to split the non-transported business and the transported business. Your question is very natural, I think. And when we think about the transportation business, it is profitable. And also, for the non-transported business, it is also profitable. And of course, we cover east part, we cover east part of Honshu main island. And in this cases, we cover this area, East Japan Railway Company. And we have a Tokyo metropolitan area. This is virtually profitable for us in terms of transportation only. And high-speed rail, this is also very profitable for us because we have lots of much riderships. And but we have many regional rail, local rail. And actually, to tell the truth, we do not have any statistics open to the public. But actually, to tell the truth, for this area, in the rural area, network produces lots of deficit instead of profit. So these profit comes from Tokyo metropolitan area, and the high-speed train covers the deficit producing these regional areas. But still, we just produce a lot of profits.
From the rail?
From the rail only.
Only?
Yes, I'm talking about the transportation only, right now.
Well, please do go to the American government.
And also, we didn't raise our level of charge and fares in the quarter century. Yes, and also next quarter century, of course. Yeah.
Right.
So yeah, thank you. And also, thank you very much. And also, we have already made a presentation to the government officials in the United States in many places. So I think I agree with you. It is very important for us. And we really think that we try to contribute to your country, to the nations, and to your people. So not just for something like that, sales or something. our feeling is that just we'd like to contribute to the United Nations, because we think it is very important for us to have a better relationship between Japan and the United States.
Thank you very much.
You are very welcome. Did it answer to your question?
Yes.
Okay, thank you.
I have several questions. First of all, you mentioned that you have a power station,
Yes.
both hydraulic and
Yes.
thermal.
Yes.
What's the total wattage of power station? Gigawatt?
Yes.
10 gigawatt?
Yes.
How much power do you have?
Yes. In terms of kilowatts hour, is that okay for you?
Kilowatt?
What hour?
Not hour, kilowatt.
Kilowatt, okay. Anyway, more than million kilowatts. More than million kilowatts.
That's 1 gigawatt.
Yes, yes.
So just one power station, average one power station.
Maybe you have the bigger one, I think.
So 150 is 2% of the total Japanese energy consumption. And
Maybe, I don't know, but anyway, we always told
it's
1
probably
million
not
kilo-
very
kilowatts.
unsatisfactory.
No.
You have any plan to increase the number of power stations?
No, just say we have one hydraulic, we have summer, and okay, we may increase the total power supply for summer. Yeah, maybe because today we have
The idea.
Yes.
Well, are you trying to operate your train entirely depending on your own power station, or what's the idea? That's what I don't know.
Right now.
Or you want to use this just at the time of an emergency, or what?
Actually, on the average day, average time, we'd like to operate our trains by our own power plants.
So that's the purpose.
That's the purpose. Yes.
Another question is about this earthquake.
Yes.
I understand you have this seismometer along the shore,
Yes.
but there's another kind of earthquake,
Yes.
which is
Yes.
the inner fault earthquake,
Yes.
directly underneath.
Yes. Yes.
Do you have any device against those more probably dangerous kind of earthquakes?
Okay, and that's a very good question. Of course, besides seismometer alongside the sea coast, I've already mentioned we have 81 seismometer along the tracks, along the lines. So in this case, we cannot earn the time difference, time gap.
Yeah, that's the problem.
Yeah, so that manage. Like this. So we have already reinforced pillars and the pylons. So it's okay because derived from the lesson in the past earthquake that, for example, occurred in 1995, 16 years ago, in the different area. We derived the lesson, and so we cover our pillars with the steel plates. So it is very strong against earthquake.
I understand qualitatively, but how about quantitatively? How much acceleration or force can you stand with those things?
Yes.
In terms of gravity, 10G, 100G, 1000G.
Okay. Are you familiar with the GAL?
Yeah,
Yeah.
that's what I'm talking about.
Yeah. Actually, today, of course, GAL, GAL, is very important for estimate the aspect in the company. But in order to make a better estimation, we have invented another index, KINE. KINE is a KINE, very special index for the structure strength against the earthquake. But maybe I may convert from that kind to maybe GL, maybe more than 1,000 grams.
1,000, yeah.
Yes, it depends on, because we are using another different index. But anyway, for example, this one, Hanshin earthquake, it depends on the place, but somewhere they suffered 800 gauss or 700 gauss, something like that. And then it breaks. So then we just remodel, we just strengthen in order to avoid the destruction against earthquake, which has more than 1,000 girls in some places.
I understand you are crossing probably many fault lines. You have all these devices at every
Yes.
sort of
Every sort of
fault lines.
Yes. Yes. What do you mean fault train?
Fault lines.
Full train, yes. Full truck. Full segment.
Fault line.
Full truck.
No,
Yes.
fault line.
Of course, we just examine. We have examined all the fault lines, and at such a point, we have strengths furthermore. This is just an example. So, for example, actually in Japan there is many fault lines. So we are very, you should be very careful. But we have done this against such industry cases. Yeah. I'm not very the specialist for such issues. I'm a specialist for safety, overall safety, and also operational maintenance. But we have already done countermeasures, including such a geographical structure.
Yes, thank you. Go ahead.
You mentioned safety, and what I was impressed with was that despite the fact that 20,000 people lost their lives, almost all of them by the tsunami, no one died as a result of that on any of the trains along the coast.
Yes.
That's remarkable.
Yeah.
To what do you attribute that?
Of course, with some fortune, but as I've already mentioned, actually, these trains was completely washed away with the entire city and towns. And in this case, including in these cases, our staff successfully led our customers to the evacuation places. So, but there did exist some exceptions. Okay, our staff successfully led our customers to the evacuation place designated in advance by the local government. And after our crews sent all the passengers to that evacuation places, then our passenger got together with the residents nearby. But after that, tsunami came, and tsunami washed away the evacuation places. So this kind of example it just existed, unfortunately. But anyway, what I'm meaning is that zero. What I'm meaning is that we successfully led our customers before the tsunami hit. So even though the train, empty train, an empty station was washed away with the entire town, but no injuries and no fatalities, including a high-speed train and conventional trains. Almost 700 trains, 700 operations.
Okay, last question. Last call. Yes, University of Maryland.
Do you feel that such a train system could operate without subsidy on the eastern coast of the United States?
Oh, yeah.
Because of the population issue, the number of people who would use a train.
It is very difficult question for me to answer, but
Yeah,
I have already read about the project, future projects, many projects, future projects, and of course we had already get in touch with the people, professional people, railroad, and according to my opinion, of course we have to manage it very well, but population change through many cities on Northeast Corridor makes the high-speed train possible and feasible and profitable. Because yours, population distribution between Boston through New York City to Washington D.C. Has much more attractive for the high-speed train. But the problem is that, of course, about budget, capex, capital expenditure, capital cost, initial cost, and also operational cost. So we'd like to contribute in terms of the reducing the initial cost and also reducing the operation cost, reducing the maintenance cost. So we have many knowledge and experience. So we'd like to do that. So right now, we are at stage of a make-up presentation to the government, of course. Thank you.